Lesson 1-8, Divide Integers. Explain it. The shapes below are used to show the relationship between each of the four equations in the same fact family. Try to answer part A, pause the video, and come back and see if you did it correctly. If the star represents a negative 24, then the blue square must either be a positive 8 or a negative 8. If the blue square is a positive 8, then that means the red circle has to be a negative 3. However, if the blue square is a negative 8, then the red circle must be a positive 3. Part B. What do you know about the square and circle if the star represents a negative number? Pause the video, try this one, and come back. Check your answers for Part A and let that help you with Part B. In order for the star to be a negative number, what that means is that the square and the circle must have different signs. One of them must be a positive integer and the other one must be a negative integer. Now take a look at Part C. What do you know about the star if the square and the circle both represent a negative number? Pause the video, answer this, and then come back and check. If the square and circle are both negative, then the star has to be positive. Take a look at the last piece on this page. Focus on math practices. Suppose the square represents negative 8 and the circle represents positive 3. Use what you know about integer multiplication and the relationship between multiplication and division to write the complete fact family. Pause the video, try this, and come back and check your answer. Hopefully you were able to make the two multiplication equations without a whole lot of difficulty. Now pause the video and see if you can do the division parts of that fact family. By using the idea of a fact family, you can easily see how those three integers are related to each other through multiplication and division. We're going to use this idea as we explore dividing integers throughout this lesson. Take a moment to read through example 1. In this example, we're going to learn to divide integers that have different signs. Pause the video while you read through the question and the solution, and come back for more information. For this problem, notice that the machine drill drills down the same distance each day for 4 days. The total distance covered was negative 160, or 160 feet below ground. That means that each day the machine drill would have had to have drilled down 40 feet because negative 40 times 4 is negative 160. And you can see that right. Oops, there we go. Let's try that again. You can see that right here. So when we look at this from a related fact family, you can take the multiplication fact and turn it around into the division problem that means the same thing to see how to divide those integers. Also notice this little blurb here that I have highlighted and circled and starred and all sorts of things, okay? When you're dividing integers that have different signs, the answer is going to be negative. But notice how you don't change it the way you're dividing. You simply apply the sign to your answer. Now complete the try it. Come back to check your answer when you are finished to see if you did it correctly. Notice in this problem, we took the division and we changed it over to a related multiplication fact because we are looking for what that question mark is equal to. In this case, 3 times what number makes negative 84? Well, that number has to be a negative 28. And you can see on the number line over here to the right that each of those 3 movements was in an increment of negative 28. So on the number line, you go down to negative 28 for your first move. Going down 28 more puts you at negative 56. And then the final movement of down 28 puts you at a negative 84. So what we know is that when we turn this back into a division problem, negative 84 divided by 3 is a negative 28. Now try the convince me. What we know is that we can use the idea of these fact families to show that the rules for multiplying integers also apply to the rules for dividing integers. In other words, when we multiplied a positive and a negative together, the answer was negative. Likewise, if we divide a positive and a negative number, the answer is negative. So the rule is the same for division as it is for multiplication. Example 2. Divide integers with the same sign. So when I look at the first question here, simplify negative 27 divided by negative 3, there are two ways to approach this. One way is to use the related multiplication fact. So you can see how they turn the division problem here into a related multiplication fact where we replace the question mark and now it's in the multiplication problem. So the question is, what number can I multiply by negative 3 to make negative 27? That answer is 9. So when I turn this back around into its division problem, I have negative 27 divided by negative 3, and that also has to be that positive 9. So when you are dividing integers with the same sign, the quotient is positive. I'm going to go ahead and highlight that here as well. Another way to do this is to think of this as a fraction. Remember, division and fractions are related because that fraction bar is another way to write a division sign. So as you can see here, they've turned that negative 27 divided by negative 3 into a fraction form. And then they took and factored out a negative 1 from both the 27 and the 3. And those two negative 1s here, okay, one's in the numerator, one's in the denominator, essentially cancel each other out because any number divided by itself is equal to 1. So 1 times 9 is a positive 9. Same answer as the right, or on what you see on the left side of your page, the first way that we did it. But this is just another way to think about it. And again, if the sign is the same on both integers, like you see here, a negative 27 and a negative 3, it will produce a positive answer. Now complete the try-its and come back and check your answers. Notice that for try-it part C, 0 divided by anything is 0. It doesn't matter if you're dividing it by a positive or a negative integer. Example 3, write equivalent quotients of integers. So the question here is to take a look at these three division problems, all with fraction forms, and to determine if they are equivalent and to justify your answer. In each case, you can turn this into a division problem. And then your job is to determine if that answer is going to be a positive or a negative number. In the case of the very first fraction, notice that the negative sign is in front. It's in front of the entire fraction. So it's also in front of the division, 18 divided by 4. So what I'm essentially looking for here is the opposite of 18 divided by 4, which means the opposite of 4 and 5/10, which is a negative 4 and 5/10. In the second example, I have a negative 18 divided by 4. Again, negative 4 and 5/10. And in the third example, I have 18 divided by negative 4, which is still a negative 4 and 5/10. The generalized rule over here simply states that if there is a negative sign in front of a fraction, as you see here, that it is equivalent to if that negative sign were in the numerator or in the denominator of that fraction. Now complete the try-it and come back and check your answers when you're finished. Out of those 6 division problems listed, 4 of them are equivalent to negative 5. Make note of the key concept. The rules for dividing integers are related to the rules for multiplying integers. In other words, they're the same. So if you look here at the two examples for each of those, if the signs are the same, the quotient is positive. That's this right here and this right here. So two negatives or two positives will produce a positive answer. However, if the signs are different, as you see in the third and fourth examples here, the answer is negative, just like with multiplication. Now I want you to try question 4 and come back and check your answer. Even though question 4 is written in the form of a fraction, each of those is still a division problem. Check your answers before going on to the next slide. Now try questions 5 and 6. Again, pause the video while you try them and come back and check your answers. Check your answers to question 5 and 6, and then go on to the next slide. Now go ahead and try questions 7 through 12. Notice that I circled number 11 in red. That one I want you to focus on because I know that one shows up later, like let's say, for example, on a test. Once you have finished working through numbers 7 through 12, come back and check your answer. Now take a few moments to check your answers to 7 through 12. Go ahead and pause the video while you do this. Now we're on to 13, 14, and 15. Try these questions and come back and check your answer. Go ahead and check your answers to 13, 14, and 15. Although I don't have the number line to show you on number 15, you can see where those integers are located, and you can plot those points on the number line. There are two problems there that are undefined. Remember, you cannot divide by 0. So -4 divided by 0 and 9 divided by 0 are both undefined. Next, try numbers 16 and 17. Come back and check your answers when you're ready. Go ahead and check your answers for 16 and 17. Pause the video if you need to, and we'll move on in just a moment. We're going to skip number 18. That's not one that you're tested on, but I am going to ask you to do numbers 19 and 20. So again, pause the video, try 19 and 20, and come back and check your answers when you're ready. Go ahead and check your answers to numbers 19 and 20. Notice that I gave you a possible explanation in part B of number 20 for the cause of Eva's error. Once you have finished these two problems, you're ready to move on to your assignment.